Hello guys, so we're back with live streaming. This day we're going to look at coding conventions. I hope it will be a little bit shorter, but it might be a little bit boring, I expect. Last time we saw how data classes work. They define objects with properties and methods using the class keyword. Data class keyword, actually. There's an issue here. You can have some predefined methods in which equals compares all the property values between two data classes. And this is different from standard classes. In case of standard classes, equals won't work. Then okay, you have toString, which is a readable representation of the object, and then we have also seen the copy, how to copy the object of a data class, and that you can also add some arguments to this method in order to change the value of one or multiple arguments after the copy, of course. Then we have seen the use of filters. We have seen that you can do instance check with when, but of course when can also be used to as an if condition. Yeah, as an if-else condition check. Then we have also seen how maps work. Basically, maps contain keys and values, and given a key, you can access the map's value. You can only have one key, so the keys are unique inside the map. Yeah, one key with the same name, let's say, with the same. With the same name. It depends. It depends on the type, of course, that you define for the key. In case of, for example, strings, you will have you cannot have two equal names with the same on the same string. Then we have lazy operator. We have seen that these operators are only computed on first access. Then we have seen extension functions that basically allow you to extend the methods of a type, a certain type. For example, you can extend string to have space to camel case function. That will, of course, give the camel case representation of that string. Then we have seen singletons, their design pattern, which allows you to have one instance of the same object throughout the project that you are working on. And we have seen abstract classes, which cannot be instantiated directly, and they need to basically you need to implement this class in order for it to be instantiated later. Then at last we have seen with, apply, and also, which are very useful. For example, with, you can use it to access multiple properties or functions of an object. Sorry. With apply, you can basically it's useful if you want to change some arguments of an instantiated object, and in the context of configuring it or initializing this object. And also is useful to perform the additional actions after initialization, I would say. And these objects are accessed the with and apply with the with and apply you can use the receiver type this, and with also you have to use IT. That's the main difference. Okay, we can go to coding conventions. So coding conventions are, let's see what they say here. Commonly known and easy to follow coding convention are vital for programming languages. Here they provide guidelines on code style and code organization for projects in Kotlin. Yeah, you can configure the IntelliJ and Android Studio to format your code automatically. This is quite useful, so if you want to try it, basically you can follow the steps that you have here. And okay, on Android Studio maybe we can check that. Let's see if I can open a project very quickly. Okay. Shoot. Open GitHub. Let's open the same project in Android Studio. Should be this one. Nope. Huh. Cannot find the project. Alright, maybe we skip it. We will see it later, okay? If we have time. So, let's see what they say here. Source code organization, directory structure. In pure Kotlin projects, the directory structure follows the package structure with the common root package omitted. For example, if all the code is in our example Kotlin package and its sub-packages, files should be placed directly under the root. And in network socket they should be under network socket subdirectory. Okay, that's I would say quite understandable. I want to see if I can open the project and somehow let me check. I'm updating Fleet, so okay, it should be updated. Let's see the Fleet. Okay, now I have the, so it's in GitHub courses. I have the directory also in order to open it in Android Studio. I don't know if coding conventions are available in inside Fleet. Probably they are only available in Android Studio as of now. Let's see. Yeah, the coding conventions, settings, preferences, editor, code style, Kotlin. So I will go and show you settings. preferences. Let's see again, sorry. Settings, yeah, okay, editor code style Kotlin. Editor code style Kotlin. Where are you, Kotlin? Here you are. Okay. Okay, so what it says here, apply the style guide, click set from, select Kotlin style guide. Set from Kotlin style guide. Set from Kotlin style guide. Okay. So verify that your code follows the style guide. Switch on incorrect formatting inspection. Additional inspections that verify other issues described in the plan are enabled by default. Let's see if we can do this. Settings, editor, inspections, general. Editor, inspections. Inspections, general. Incorrect formatting. Incorrect formatting. Okay. Severity weak. Okay, so you can specify the severity of this. I didn't know it. So you can say weak warning. I prefer to leave it like this, weak warning. Let's see if we're able to somehow see what happens inside our code. I believe that we have to check in problems. Probably the IDE is still working to analyze the app. Okay, so you see we have a lot of suggestions here. I also have a macro. I don't remember how I've set this up, but basically each time I save, let's see if I can check it. Macro. Each time I save with Ctrl S, I get some that the code is formatted again. So macro to save in Kotlin Android Studio. Macro to format code with save. Let's see. I suggest you to enable this. So file settings. This is for Flutter. Code Kotlin. Macro. Okay, so edit macros. Oh god, they've changed. Edit macros. So this is very useful. Yeah, you see format code on save. Ctrl S will format the code. I can show you here. You can add this macro and perform some actions. I've also, yeah, it does optimize imports and auto indent lines. You can set up this macro from here. So you, yeah, enter a new name, test. I can say, oh, I've changed this, sorry. Format code on macro. How can you add a new macro? This is just remove. Edit macros. Yeah, start macro recording. Sorry. Start macro recording. This one, like I can say Control D. And now it's basically duplicating, so Control D does that. Yeah, so the meaning, what you should do here is, for example, add something that you want, like format code. So I could go here, comment. So now I have done 3 duplicates and 1 comment, and this macro will record that. If I stop the macro, it will do that. Test. So if I hit Control D, it adds. It should add. It should add 3 brackets and 1 and 1. Yeah, maybe we have also to assign the macro to to a certain shortcut, probably. Yeah, you see it here, it's Control S. Here it's not assigned to a certain shortcut, and you should assign this to a shortcut for it to work, so we can delete it. That's my suggestion, use macro to format code. Let's keep on seeing the coding conventions. Sorry, I also have some issues with the throat today. So as you see here, we are in package org example. We are in this package that has org example package, and we are inside the proper directory. If, for example, I want to show you this test, you create a file with the wrong package name, test, and like this, it will complain. It will say that the package directive does not match the file location, and that's what they're also saying here. Yeah, I have to remember. So you should be in the proper directory. I think this will be handled at compile time, but follow the IDE suggestions and we will be okay. Source file names. So if a Kotlin file contains a single class or interface with top level, it should the name should be the same as the name of the class. So I shouldn't call this something else like Java. Although this is allowed, it should be the same name as the file, if it's a single class or an interface. Okay, so I can say more data.kt. Yeah, I haven't added these. Okay. Right. Next, let's see what they say. If a file contains multiple classes or only top letter declaration, choose a name describing what the file contains and the name of the file accordingly. Use upper camel case where the first letter of each word is capitalized. So if I have a class or an interface, yeah, this is also useful because if you will see that if I rename the interface, it will rename also the file. Yeah, if I rename the file name, the interface will also change its name during the refactor. So test data. You see here what I mean? So it has changed both of them. And here it was saying that you have to use camel case if we have a name that has more than one word. Yeah, in multi-platform projects, we'll see this when we talk about multi-platform. We have 3 directories: JVM, Android, and iOS. Maybe also more than that. And there is a convention for specific code in each of these platforms. Yeah, you will see this later. So source file organization, placing multiple declarations, classes, top-level functions, or properties in the same Kotlin source files is encouraged as long as the declarations are closely related to each other semantically and the file size remains reasonable, not exceeding a few hundred lines. Particularly when defining an extension function for a class which are relevant, put them in the same file with the class itself. When defining extension functions that make sense only for a specific client, put them next to the code of that client. Avoid creating files just to hold all extensions of the same class. Okay, so what it's saying here is that if I have a class which is maybe let's rename these to products. I want to maybe a data class called products, or actually this should be product. Then I can say product name string, and this will be the initializer of product. Well, so what he's saying is that if I have an extension function of product, like I don't know, product fun, add product function body. Remove. Then this can be in the same file name, and I should not create a class called extension.kt if this function is related to product class, because you can do this, nobody will complain, but it's better for clarity to have the extension function in here, because when you see product you will see also the extension function. So class layout. The contents of a class should go in the following order: property, declarations, and initializer blocks. Okay, so we should have property declaration, how is added, maybe boolean false. So when you add the product, this will be true. And you can have is added true. This has to be a variable. Okay. And then property declarations and initializer blocks first. So property declaration is this one, and initializer block is this one. Maybe let's see if we can do this. I'm not even sure. False. You can. So you can have let's see if it complains. You can have the order should be property, initializer, secondary constructors. So if you have a another constructor here, this is not possible, this primary. It's actually possible, but there's a cycle. I'm not sure if you can call a constructor inside the data class which already has a constructor. Don't think it's possible. I mean, I think we can create multiple constructors in a standard class. Let's see. Yeah, maybe we have to. Yeah, maybe we have to add this name string. Yeah, we have to add surname string. Okay. Now, if we add val surname, we might. This might work. Let's see. Surname. Yeah, it should be initialized maybe to null. So we could do something like this. This calls the primary constructor, but we also want surname to, yeah, this surname to be equal to surname. So basically what I'm doing here is I've created another constructor which adds an optional surname, and this should be declared after the init, which is the primary initializer, which is basically it will run after val name is declared. I mean, when you pass the arguments, the constructor will run, and it will run also initialized, the initialization class, the initialization function, which is this one. And if we have a secondary constructor, I expect this secondary constructor to run after the primary constructor, and after secondary. Primary. Yeah, we should test this because it might be kind of useful for you. So I will comment everything until I decide to make some order here. Let's see. Lesson. Okay, we need some configuration. Maybe we can switch to fleet because we have a running configuration here. So let's see if everything is fine. It should. Third lesson, so we declare a product. We import the class and we say product name Apple, and we run this, we run it. So what we've done here, we have created an initializer. We have a secondary constructor in which you can pass surname. As you can see, we have only passed name at this point and not surname, and the constructor has so the constructor has only one value, and it's only running this initialization function. If we add a second product like eggs, and we also pass surname, it doesn't make sense, sorry. We also pass name and description, maybe description. So description, I hated that the shortcuts are different between Fleet and Android Studio. Description, and now boil some water. I don't know what to say. I hope, yeah. So it says initialize. This is for the first product. Second product will run initialized and running secondary after primary constructor, because we're also running this code now, and this, which is the primary constructor and initializer, are running before this print line. Okay, perfect. Let's go on. Then we have method declarations. So we have functions, like we may have delete product, I don't know, description. So what we may have is this description equals to null, and then we can do this to wrap it, so it will yeah, maybe we can say null because it's nullable. So this will delete the product description, and it's after constructor. Last coding convention, let's see. Companion objects. Okay, so I have actually all the time I've had companion objects, I was declaring them at the start of the class, but they say they should be here, so we'll follow the guidelines. So in a companion object, I don't know, you can have a tag, for example, product. So for example, if you want to have a toString method, you can say, that's what I usually do. I say, okay, we can say superstring this time, and then we can say tag. So we do our custom logger. This should, if we print it, should show all the products that we have. Okay, so, oh, it's because it's a class, not a data. No, it's a data class. Strange. I thought this would have printed the objects. Let's try it with let's do like this. So without our change. Huh, that's strange. Why? I'm not sure why. If we use the override, it will not take the data class toString method. That's interesting. Maybe. Let's try like this. No, it complains. It complains. That's strange. So we have to do our own? That's strange. Okay. So let's say name and description and product. So yeah, we could have something fancy, but okay. So this is the tag. Sorry, we will not type tag. So we are using the companion object tag, and this can be accessed also outside, I think. Yeah, outside of it. Yeah, maybe it's private. let's see what I've written. Unresolved. Yeah, that the companion object is probably private inside the product. Or no. Companion object, second product dot tag. Let's try and print it and see if it fails. Result reference tag. So yeah, you cannot access it. You can only access it inside the class, probably. All right. Probably this is because it's private. Let's see. No. So maybe this can be public. No, it's still the same. So yeah, this is the companion object means only objects that are accessible inside this class. Makes yeah, you can add properties here that are accessible inside the class. Next. Do not sort the method declarations alphabetically or by visibility, and do not separate regular methods from extension methods. Instead, put related stuff together so that someone reading the class from top to bottom can follow the logic of what's happening, choose an order and stick to it. Okay, so it's not important to sort. Yeah, logic. You have to sort in a logical manner. Put nested classes next to the code that uses those classes. Okay, so if you have a nested class inside product, what could be nested class inside product? I don't know. Like, yeah, it's a bit strange. Could be an wait. A wait data class. Let's see if it works. So we can say wait data class value and how do we say that? A value unit, like unit, it could be unit, like string. And here if I declare a variable weight of string, of weight, this could be nullable. We could add a weight, and this comes from a data class. So if it's not reused across the project, we can declare it inside this function, and I'm placing it right above the weight because it's more logical. That's what they're saying. So interface implementation layout. When implementing an interface, keep the implementing members in the same order as the members of the interface, if necessary. Yeah, okay. Interspersed with additional private methods. Okay, so this is, let's say that we have delete. Let's say that we have an interface which is this one, create interface, extract to separate file, fun, delete products. Now you will see that we need to override because we're declaring an interface and we want to implement this interface, and since it has this method that I've copied from here, it will ask to override it because it has the same signature. So what did you have to show? Yeah, if we have methods that come in that are private and like, I don't know, it could be something very simple like delete product description warning. So we can create this function. It automatically creates it below. So I think this is the best practice to place them below the function, but you should not place this like here or in some other parts of the code. If it's related to this function, just place it near this function. Like we are now deleting the product description. So that's what they're saying here. Overload layout. Always put the overloads next to each other in the class. I don't even know what this means, overload layout in Kotlin. Maybe let's just okay, I think I know what it means. Always put overload layout next to each other in a class. It means that if you have that's kind of difficult to show here. Doesn't make sense. Yeah, like maybe we can do change product description, description string, and then we override it in product, like implement members. Okay, so it's adding it here, we remove it. Change product description will do this dot description equals description, and what they're saying is that if we have another, maybe it's better with weight, so change weight. Okay, weight, change weight, and here we do weight, and here we do weight. Oh shoot, yeah, we can do it, perfect. Then we do, let's change this, implement members, we delete this one, remove this one here, change weight, and we have this weight equals to weight. So we have this function now, and what if we had something a little different, like weight value? So if we want to, for example, change the weight, but we don't want to pass a new weight data class, but only the value, we can do that. But first of all, we cannot have two classes with the same signature. we can have this two classes with different signatures. Signature comprehends also the arguments. So if we implement this member now, what it has done, as you see, is they have added change weight next to change weight. So you shouldn't have this. They're saying change weight should be all next to each other, and in this case you would do just weight value equals weight value. And of course this is not, oh shit, I have to do integer. This is not doable. Change function signature. Nope. Oh my god. We want to have integer here in the interface. Now it's working. But yeah, of course, if it's not there, maybe we should create the weight object. Let's try and see. Value. Right, this is a little bit tricky. Maybe we should do something like let. We have not seen this yet. Or maybe apply. Yeah, so that we can change the value, and if it's not, if it's null, so if this weight is null and we're changing weight, we could create this weight with the weight of weight value, and then we may assign a default value for the unit, like, I don't know, kg. Hope this sounds fine for you. So basically we're assigning a value if the object weight is already there, and if it's not there, we're creating the weight object and assigning a default unit like kg. So next, what we can see is naming rules, package names. Let's see how much we have. Oh my god, a lot of stuff still. Let's drink some water. Okay. Names of packages are always lowercase and do not use underscores. Yeah, concatenate them or use camel case. If you have yeah, it actually says so. So basically, if you have package name that you want to name something like test product, you should do like this. Oh gosh, it does not change this automatically. That's bad. Maybe let's see if we can do refactor. Yeah, it's rename without refactoring. It's probably missing this feature in this IDE. I think that in Android Studio you can do this. Let's try it. Let's rename this back to test and test it with Android Studio. Refactor, yes. So it should work. Let's see. Product. Yeah, it did. So it's missing this feature in in here. Now I'm very happy. Okay. Next, name of classes and objects are use upper camel case. So if we had product, yeah, like product interface is correct in this case. Oh god, why the scrolling is not working properly. Naming rules. We are here. So function names. Yeah, they follow lowercase letter first and then camel case with no underscores. So yeah, we have already done this in our examples. So yeah, it says so the interface exception factory functions used to create instances of classes can have the same name as the abstract return type. So the interface should be full and the implementation should be impl. I've done this wrong, so we can fix it, right? So let's change this. Yeah, actually I think this has a reason why it's like this. So now I have to change this first. Product imp. So it's the implementation. Yeah, this could be private, right? And then product interface. Right? So it should be like this. Next, name for test method. Okay, in tests you can use method names with spaces enclosed in backticks. So that's useful because it will be more understandable. Yeah, and a set method are only supported by Android runtime for API level 30. But yeah, this should be a test method. I don't know if it's even possible to define test methods here. Test only. Test method. Yeah, you can. And what we could do is we could say this is a test method, and maybe what we can do here is say this dot weight equals to weight value 1 and kg. So we're making our test, so we're assigning a weight and we're printing this weight. Yeah, maybe we could do print line or assert, which is something used in tests usually, and we can specify a boolean which is weight equals to weight 1 kg. So we're checking if the weight assigned here is correct. Or maybe we could do it more at instead of add product change weight. It's even better, a better test. And then we could call this test, for example, also from the main app. Scroll down and say second product imp, and then we can say this is a test method, and we can call it alright Kotlin unit. What did I do wrong? Change weight. Yeah, the assertions. Yeah, so I'm printing test method, but test method is not returning anything actually, because Usually test methods only do the assertion. So this was wrong. What we could do, yeah, is make this test fail just for the purpose of testing, and you will see an exception. Yeah, it's not making the exception. Crazy. Probably because we're marking this with test only. Who knows? Should throw. Yeah, so maybe it's not throwing the exception. Throw assertion error. It should throw the exception. Oh my god. They are different. Let's see. It's not triggering the exception. Let's see the weight then. I don't know why. And run. Yeah, the weight is properly set. And they are different. Why is it not triggering this exception? Yeah, assertion enabled. Maybe we're not in tests, so we're not running it with the test or something like that. And since yeah, maybe we have to run it with some Gradle test mechanism that I'm not aware of at the moment, because if you see here, they're checking if assertions is enabled, and I think we don't have them enabled. We could check it, but I don't want to lose time now. So to do, check why assertion is not triggering the exception. That's interesting though. You can keep it in mind for your code as well. Property names. So name of constants should or top level or object val properties with no custom get function that hold deeply immutable data should use all uppercases. So what I've done here correctly is I've declared a constant tag in uppercase, screaming snake case convention. Name of top level or object properties which hold objects with behavior or immutable data should use camel case. Okay, so mutable collection, like yeah, we could do private all. What can a product have? Yeah, ingredients, maybe. List of strings. List of. And that's the convention to use. Names of properties holding references to singleton objects can use the same naming style as object. Alright, so name of properties holding references to singleton can use the same naming style as object declarations. Alright, so comparator person comparator. Alright, we have never seen enum classes, but basically, yeah, I'll skip this. I'm not understanding this line actually. Name of properties, holding references to singleton objects, like comparator, maybe a singleton object can use the same naming style as object declarations. But so this is with uppercase at the start. So this might be a singleton object. No, I'm not really sure. Comparator might be. Let's try it because maybe we understand. Yeah, so this product. What's this? Comparator. Type alias for Java util comparator. So it's a set of functions to compare values. All right. To compare the two products, I believe. It should be with uppercase. It's saying even here that it should start with lowercase. Oh my god. Then I don't even know what we have to do here. Comparator. We have to create someone that implements this comparator, like product, maybe. It does not have constructor. Okay. Interface product does not have constructor. Yeah, because I have to do product int. Yeah, because I have to. Yeah, I don't know which object, what implements this comparator in Kotlin. I'm not sure what implements comparator in Kotlin. So I'm just copying an example here. Comparator might be implemented by. Okay, let's do string for this example. Let's see if it's okay for him. Yeah, this should go first. Now it's okay, so basically a comparator is an object, as you see here, that overrides, which in this case we're overriding only compare. I think we can override also other functions like equals, and this will for example return the difference between the two lengths of these strings when using the comparison. And he says person comparator should have uppercase. Yeah, here it says lowercase. I don't know. Let's see what it does if we convert to lambda. Okay, it's even more clear syntax, but this might be easier to understand. So we're making an object that implements comparator string and overrides this method. So probably we could use this person comparator, I don't know, to check the difference between what we could do is check the difference between two descriptions. So let's try this. Check difference between, check length difference between descriptions. Person comparator compare this does description with another description. Who complain? We can have null. Yes. So I mean the ID does not agree. Says this should be lowercase. Okay, so we've seen also this comparator convention style. So anyway, the object should have the same convention as for the other values and variables. We can have also enumerators. We have not seen this, but for example, if you want to have an enumerator such as color, and in case you will define an instance of this class, you can only have these two values and not something else other than red and green. So let's try, and we're lucky because we can use it here. So we have declared a data class. What we can do is we can declare also enumerator class, which is unit, and then we can say kg and libs. I don't know, libs, lbs. The shortcut is this, and now instead of having a string unit, we can have unit here. Now it will complain, it will say, hey, you're giving me a string. We'll give him a unit of kg now, and now it doesn't complain anymore. Same here, same here. Okay, and you cannot have something different from these two values as a unit now. Woo, there's so much stuff still. Choose good names. If a class has two properties which are conceptually the same, but one is part of a public API and another is an implementation detail, use an underscore as the prefix for the name of the private property. Okay. So that's that will be used in in Kotlin to define backing properties. So basically the elements list with the underscore is a private backing property, and the element list is only used to access to view this element basically. So this is a mutable list, as you see, and this is a list. So we can have the same concept here for ingredients. We can have a private ingredients value, and we can have an ingredients, this should be mutable list, and this should be mutable list. So the mutable list is a list in which you can add elements. In a normal list you can only override the whole list, so it's more efficient to add elements to a mutable list in Kotlin. We can see this now. I will show it, and then you can have a backing property, which is this ingredients. Sorry, this is probably not the backing property, but this is a property which can be read by publicly, and it will basically return as a list ingredients. So here it's doing a casting from mutable list to list. It's probably done underneath, because here we specify a list, and it's not complaining. It's not complaining to the compiler, to the IDE or compiler. So it's basically doing the toList on its own. Or probably it's because, yeah, this implements list. So this is why we don't need to do anything else other than this in this case. Next, let's add ingredients. We have not done this function. Add ingredient. In this function, we will add an ingredient. So we can say, yeah, as you can see here, I don't have add inside the list, but I only have it in the mutable list. Okay, so the ingredient I think is a string, so I will say s, add s, and as you see, we're adding elements here, and when we read the elements, we will be able to read them flawlessly. Let's show this second product implementation. Add ingredient, test, and then, yeah, not test, maybe eggs, I don't know how to say, yolk to the eggs. So second product imp. Now I can access ingredients because it's public, and show the ingredients that I've added. Yolk. It is working. Great. Choose good names. The name of a class is usually a noun or noun phrase explaining what the class is. List or person reader. The name of the method is usually a verb or a verb phrase containing saying what the method does. Closed or read persons. So yeah, like we're seeing here, add ingredient, it will add an ingredient to the list. So it's quite understandable. The name should also suggest if the method is mutating the object or returning a new one. So add ingredient, maybe we could do add ingredient to list, but to ingredients list, but I mean, yeah, I think you can understand it anyway. Even because if you change the list to something else in the future, add ingredient I think is fine. If you don't want to use a list, maybe you want to use a map or something, it's better to leave add ingredient. For instance, sort is sourcing a collection in place where sorted is returning a sorted copy of the collection. So, okay, this is very much a detail. So add ingredient. You should, I would check what the function does in the documentation. If I, for example, want to return the ingredient, I wouldn't say add ingredient and return it. I mean, that's my personal preference, but whatever. Yeah, here it's different. Sort is sorting the collection, and then sorted is also returning a copy of this collection. The names should make it clear what the purpose of the entity is, so it's best to avoid using manager wrapper names. When using an acronym as a part of declaration name, capitalize it if it consists of 2 letters, IOStream, for example, Capitalize only the first letter if it is longer. Okay. Formatting, use 4 spaces for indentation. I mean, this if you use the macro, it will do it on its own. For curly braces, put the opening. Yeah, the macro can format code. Here you have code, and here you have optimize import, reformat code. This will reformat the code. For example, let's go here and say reformat code. Wow, now it's looking better. I'm not sure if the macros are available already in Fleet. Let's search this offline. Okay. Horizontal white spaces, put spaces around binary. Okay, range 2 should not have them. A++, do not put spaces. If when for put spaces between control flow keywords. Do not put spaces in after declaring a class name or function. Never put a space after or before the brackets. Never put a space around dot or question mark dot. Slash, this is a comment. Don't put spaces. Yeah, this is a little bit boring. Colon, put a space before the colon in the following scenarios when it's used to separate the type. Okay, when delegating to superclass constructor a different constructor after object keyword. Do not always put a space after column. Do not put a space when it separates a declaration and its type. So that's how it should be. Class headers. So I think that if we use format, it will do all of this on its own. Let's try and do this. Add ingredient. You see, it did fix it. Yes. Class headers. Oh my god, we still have a lot of stuff. Class headers. Classes with a few primary constructor parameters can be written in a single line. Okay, so in this case, single line, longer headers, multiple lines. Also, the closing parenthesis should be on a new line. If you use inheritance, the superclass constructor call, or the list of implemented interfaces should be located on the same line as parentheses. Okay, this is just not so useful. For multiple instances, the superclass call should be located first, and then each interface should be located in a different line. Okay, that's reasonable. For classes with a long supertype list, put a line break after the colon, and again align all supertype names horizontally. So all of this is done by the format that I've shown you, so I wouldn't really go through this. To clearly separate the class header and body, put a blank line after the class header. Okay. Modifier orders. Public, protected, private, internal. Expect actual. These are for multi-platform. Final, open, abstract, sealed, const. Okay, these are all modifiers. Annotations before modifiers. Okay, so yeah, if you have an annotation, should place it before. I don't know what this even does, but we can declare it like this. Maybe it's explained. Metadata definition. Annotations. Yeah, still place annotations on a separate line before the declaration. Yeah, maybe G's field. There's no effect on a private property. JSON exclude. Yeah, this probably comes from serialization library. Okay, single annotation without arguments must be placed on the same line. File annotations. Okay, functions. Yeah, this is all done by the formatting. Why would you use it? Put and set on separate lines. Control flow. Let's keep this. Come on. Method calls. Chained. Lambdas. Training commas. Okay, then documentation comments. You can use these for multiple line comments and this for one line comment. Generally avoid using param and return tags. Instead, incorporate the description of parameters and return values directly into the documentation. Well, what I usually do when I want to make some documentation is I start this, and then it will copy the property names, and I can say this is a product class to store information about the product. And if you want to comment something inside the code, like change weight if the weight is not defined yet. Yeah, like create weight if the weight is not defined yet. Avoid redundant constructors. Alright. Function, yeah, don't use unit if you don't need to return anything. Semicolons. String templates. Okay, string templates, we have seen them already. Idiomatic use of language. This is still quite long. Language features. Immutability. Prefer immutable data to mutable. Always declare local variables and properties as val rather than var if they're not modified after initialization. So always declare val, and then if you need to change this variable, you can use variable, but only if you need to. Always use immutable collection interfaces to declare collections which are not mutated. When using factory functions to create collections instances, always use functions that return immutable collection types when possible. So yeah, so it is saying you should do something like we have done for ingredients. Use a backing property to have a private mutable list and a value of ingredients which takes the list value for reading. Default parameters. Okay, you can declare them. Yeah, if you have a default parameter, you should not declare it with a function like you're doing here. You can directly place them in the constructor. Yeah, not in the constructor, sorry, in in the function arguments list. Type aliases, you can have these type aliases, might be useful in some cases. For example, if you have what we could do, unit is not, we could here it's saying person index type alias. We don't have an example for this yet, but you get the idea. Type alias is an alias of the type. So if you use person index, it's the same as using map string person. Lambda, it's recommended to use IT instead of declaring the parameter explicitly. Okay. In nested lambdas, always declare parameters explicitly. So that's kind of difficult to show here. We'll see it sometime in the future, I think. Or maybe, let me think. So when you do the let or apply, you can specify. Oh, maybe in the apply you cannot. Sorry. We have never used let. God. So I cannot show it here. But we'll see this later on. Returns in lambda, avoid using multiple labeled returns in a lambda. Consider restructuring the lambda so that it will have a single exit point. If that's not possible, consider converting the lambda into an anonymous function. Named arguments, alright. Always use named arguments if you have multiple parameters. Conditional statements, you can have expressions like this or like this in the return directly, and basically it is saying that why it skips. It is saying that you can use return before not in Java. If you're used to Java, maybe you're used to this, but the compiler will always suggest to use this. Not the compiler, but the IDE will always suggest this syntax for Kotlin. If versus when. I'm not sure. For binary conditions, use if, but if you have multiple multiple cases on the when, maybe you should use when. Guard conditions. Use parentheses when combining multiple Boolean expressions. So it will be also suggested by the IDE to use multiple to use parentheses to clarify the if. If you need to use a Boolean, check the value with equals true. This is also suggested by the IDE. Prefer using high order functions like filter and map to loops, exception for the for each. When making a choice between a complex expression, use multiple higher order functions in a loop and the loop. Understand the cost of the operation being performed. and keep performance consideration in mind. So, okay. Loops on ranges. That's what you should do, not this. Oh, that's because probably have certain operation, an operator which goes until n-1. It's the same syntax. Strings. Yeah, this will also be suggested by this. If you, for example, do space, it will add the plus and construct a new line itself. Function versus properties. Prefer a property over a function when the underlying algorithm does not throw, is cheap to calculate. Return the same result over invocation if the object state hasn't changed. Use extensions function liberally. Every time you have a function that works primarily on an object, consider making an extension function accepting that object as receiver. To minimize API pollution, restrict the visibility of extension functions as much as it makes sense. As necessary, use local extension function, member extension functions, or top-level extension function with private visibility. So declare a function as infix only when it works on objects which play a similar role. Good example, end to zip. Bad example, add. So these functions play a similar role and they are declared as infix. I don't even know what the infix function is. We'll see this later. Function marked with infix can also be called using the infix notation. They are functions which can use the operator in this way. We'll see it. We'll see it later in the course. Factory functions. If you declare a factory function for a class, avoid giving it the same name as the class. So this declares a companion object from Polar, angle and radius, declares a point, but it does not have the same name as okay, so from Polar, angle and radius, you create a point. So this will be fine. Platform types. Get property name. A public function or method returning an expression of a platform type must declare its Kotlin type explicitly. Properties initialized with an expression of a platform type must declare its Kotlin type explicitly. Okay, local value initialized with an expression of a platform type may or may not have a type declaration. So yeah, here it really depends on the use case. Scope functions apply with, run, also let. Kotlin provides a set of functions to execute a block of code in the context of a given object. For guidance, refer to scope functions. Probably we'll see this later. When writing libraries, it's recommended to follow an additional set of rules. Always explicitly specify member visibility. Always explicitly specify function return types and property types. provide KDoc document comments for all public members except for overrides that do not require any new documentation. Learn more. Okay, so KDoc comments will enable you to create a documentation like we've seen before, and you can use Tokka engine to create a website for the documentation like they're using here, Kotlin Lang. Maybe we'll see this in a dedicated stream. So guys, I think it's enough for today. I hope you learned a few things. I think I will try to make the code available for you, and I will first order this a little bit because it's a little bit messy, and then you will be able to see our examples. So thank you very much. I will end the stream here and see you guys in the next one. Please remember to check the website, like and subscribe if you are new to the channel.